Hello Internet, welcome to Placement Berries. Here we are starting a new playlist that is data structures and algorithm on the perspective of placement point of view. So today I'll be discussing about the introduction part, that is lecture 1. So let's get started. So what's the prerequisites of data structures and algorithm? You should know one programming language, that should be C++, Java, Python, JavaScript or any other language you want to learn, but I highly recommend C++, Java on the placement perspective. Fine. So then next part is basic mathematics should be clear, crystal clear, like you should know functions and then set theory, Venn diagram, linear algebra, calculus, etc., at least in a basic manner. Fine. So let's move to the next slide. What is data structures and why do we need this? A data structure is a particular way of organizing data in a computing device so that it can be used effectively to perform various tasks. The idea is to reduce the space and time complexity of different tasks. So what does the definition actually means? The definition actually means like you have hundreds of millions of billions of data you have to store in such a fashion that you have to organize the data in such a fashion that you want to perform some calculation, perform some operation, perform some method so that you get a particular desired result. So you have to store in a particular organized manner. Fine. And the need of data structure is to reduce the time and space complexity. For time being, time and space complexity means how much time or space actually the program is needing in the runtime. We'll be discussing about this in more details on the upcoming lectures. So what's the type of data structures? Data structures can be categorized into two types. One is linear data structures, another one is non-linear data structure. So we'll be discuss this in our next slide in a descriptive manner. So linear data structure means in linear data structures, all the data members or the data elements will be arranged in sequential manner and each member is connected to its previous and next element. That means all the data elements starting from A0, A1, A2 up to AN, all the data elements will be stored in such a manner that you can traverse them in a linear fashion. That means one after one or one after another. The examples are array, linked list, stack and queue. We'll be discussing each one of them in upcoming slides. Fine. So let's move on to the next slide, that is non-linear data structure. Non-linear data structure has no set sequence of connecting elements or the data elements, and each element can have multiple paths to connect other elements. Such data structures support multi-level storage and often cannot be traversed in a single run. The examples are tree, graph, heap, trie, etc. What does the multi-level means? Multi-level means the data will be stored in such a manner that after first data, based on some conditions, the later on data will be stored in some memory locations on some particular relationship. An example is in your computer system, the file system. A folder you have created. On this folder you can create another folder, and on this folder you can put your image files, music files or some documents. So this is a tree-like data structures. Fine. And the graph like routing protocols are based on graph data structure. Heap can be used in memory for compiler design and such stuff. So we'll be discussing in more about this in upcoming lectures. Fine. So what is the difference between linear and non-linear data structure? Linear data structure. In linear data structure, data elements are sequentially connected and each element is traversable through a single run. What does this actually means? Means all the data elements will be stored in a sequential manner that we have discussed earlier, like up A0 to AN, all the elements will be stored in such a fashion that we can traverse the elements one after another. Fine. In non-linear data structures, we have seen that all the data structures are stored in hierarchical fashion. So it creates a multi-level paths. So coming to the next point, that is in linear data structure, all the elements are present at single level. It is very intuitive that if it is not in single level, you can traverse in a linear manner. Fine. And in non-linear data structure, the data elements are present at multiple levels. That means you can't traverse them in a normal sequential manner or in a single go. Fine. The third point is linear data structures are not very memory friendly and are not utilizing memory efficiently. Linear data structure will acquire the space in a linear fashion. That means ON. Fine. What is ON will be discussed in upcoming slides. And In nonlinear data structure use memory very efficiently. The time complexity of linear data structure often increases with increase in size. That means if we put very high number of data elements, the complexity of space and time will very much high, which can crash your system or the program. Fine. And in nonlinear data structure, the time complexity of nonlinear data structure often remains same with increase in size. That means if we increase size of the elements or the number of elements, the complexity often remains same. So I think it was a good session. You have learned about the basic stuffs of data structures. We'll be discussing each one of the data structures in upcoming lectures. So thank you guys for your time. You can write your review in the comment section and you can give us your valuable feedback so that we can provide you better material so that you can prepare for your placement drives. So all the best for your future endeavors and prepare well, study hard.